Alright, I'm going to talk about the idea of using finite differences to find the degree of a polynomial function. So here I've got a function, a polynomial function, and I've got some x and y coordinates on a table. Now, I want to know what kind of a function this is. In order to do this, you need to have the x's evenly spaced. So they could go by ones, by tenths. In this case, I'm going by fives. They have to be evenly spaced for this to work. The reason is because if they're evenly spaced here, if they were evenly spaced here, you should immediately realize that that's a linear function. If my x's are consistently going up and my y's are going up consistently, then that's a linear function. And you can tell that the difference between the y's is actually the slope of your line. If you look at this one, though, you see that that's not the case. This is not a linear function. So what do we do to find out what kind of a function this is? Well, what we do is we're going to subtract the y values from each other and get some new values. And we're going to call that our first set of differences, d1. Okay? So, what do we do when we subtract a minus 5 from a minus 57.5? Okay? Don't forget about your signs, but you're going to get 52.5. Right? What we're doing is we're saying minus 5 minus a minus 57.5. And so you get 52.5. And as we continue down here, my differences that I get 2.5 and then 27.5 and then 127.5 and 302.5. Alright, now, is this a constant difference that I've achieved here? It's not. What I've got is a new series of numbers that are not evenly spaced. And so what that tells me is that when we started, it wasn't a linear function. At this point, we haven't created a situation where this is a linear function. So we continue to subtract, and we're going to get our second set of differences. So, second set of differences is going to be the same procedure right here. And I'm going to get a negative 50 right here, and 25, and 100, and 175. Still not a common difference. We haven't got there yet. And so we continue. This is going to be my third attempt at finding common differences. But when I do it this time, I realize, oh, what's my difference here? 75. Difference here? 75. Difference here? 75. Ah, I now have it. My third common difference yields 75. It's constant. What this tells me is that because it happened on my third common difference, this is a third degree polynomial. If it had happened right here, if when I had subtracted these I had gotten a common difference on my first attempt, that would have been a first degree or a linear function. If it had happened here on the second degree, that would have been, on my second difference, that would have been a second degree. But it happened here, it's a third degree polynomial function. And I can write that in general form. I can write it this way. Y equals ax to the third power. That shows that it's a third degree polynomial function plus bx squared plus cx plus d. This is the general form for this function. But wait, how do I now find out the actual values for this function, the actual equation, without my a's and b's, c's and d's? Well, what that's going to take is, I'm looking at this, and how many unknowns does it have? Well, it has 5 things that I don't really know about: y's, a's, x's, b's, c's and d's. But remember, I do know a little bit about x's and y's. I know that given this x, you will get this y. Given this x, you will get this y when you plug it into the function. So actually, I have got values for my y's and my x's. What I don't have are values for a, b, c's, and d's. So here's what I do. I think to myself, if I have to find values for a, b, c, d's, that's 4 unknowns. In order to solve 4 unknowns, I need 4 equations. So here we go. Here's my first equation. All right, a I'm going to take my x and square it, cube it. I'm going to take this x, I'm going to square it. I'm going to take this x and just leave it, and then I have my d right here. So let's consider what we would pop in here. I can pop in for my y. I'm going to start at the top. I'm going to put in, well, actually, I'm going to start here. I like these numbers a little bit better, and they don't involve negatives. Well, they do, but we'll just start right here. If I put in a 0 for y, my x value, and that's actually not a 0, right? That is that should be a y value of 5. Let's get the y up there so we can see it. Y value of -5. So I put -5 in here. When I have a -5 here, my x value is a 0. So I put in 0, 0, 0. The next one I'm going to do is my y equals -2.5, and my x value there is going to be a 5. So -2.5 equals a times 5 cubed plus b times 5 squared plus c times 5 plus d. Alright, and let's go up with the fourth one now. I'm going to put in 25 for y. 25 equals a times, I multiply it by 10 cubed plus b times 10 squared plus c times 10 plus d. And the last one I'm going to do is going to be 152.5. 152.5 equals a times 15 cubed plus b times 15 squared plus c times 15 plus d. Here we go. 4 equations, 4 unknowns. What a mess. But wait a minute, I know how to do matrix multiplication. So I create a matrix, 2 matrices, out of these numbers. And what I'm going to do is I'm going to plug them in exactly as I see them. I'm going to have 0 cubed, 0 squared, 0 to the first power. And what is the coefficient in front of a d? That's actually a 1 in front of the d. And what have I got here? I'm going to have 5 cubed, 5 squared, 5 to the power of 1, and 1 in front of the d. And then I have 10 cubed, 10 squared, 10 to the power of 1. And you don't need to put that 1 in, and 1 to the 0. My final one is 15 cubed, 15 squared, 15 to the power of 1, and 1. That's matrix A. This is matrix B. Matrix B is my solution matrix right here. And so I get a -5 here. I get a -2.5. I get a 25. And I get a 152.5. And so when I multiply this matrix times A, B, C, and D, it equals this matrix. And if I consider this matrix A, and this matrix B, and I plug it into my calculator, all I have to do now is put in matrix A, and then hit the inverse key, multiply it by matrix B, and I will get a new matrix. And that new matrix that I get is this. It's 0.1, -1, 3, -5. And so those are my values for A, B, C, and D, which means that my final function is y equals 0.1 x cubed minus x squared plus 3x minus 5. And what you can do now is you can take this function, plug it into your calculator, hit the table button, and what you want to see on your table button is this table right here. There you go. That's the method of finite differences.